Hello, everyone, and welcome to Africa Fire Mission's weekly virtual training session. My name is Mike. I am a project coordinator here with Africa Fire Mission, and I'm so happy that you all took time out of your busy schedules to come out and join us today for training. Today, we're joined by Ed Collet. Ed has done a lot of instructing for us and is a subject matter expert in a lot of different fields. Today, he's going to be bringing his knowledge of water supply to us. I know that's a pretty challenging topic for a lot of you all, and we're hoping to have some discussion throughout the training today to try to help address some of your problems with water supply. If you stick around for at least 70% of today's training, which is usually about 40 or 45 minutes, you'll receive a certificate of attendance. If you keep an eye in the chats, I'll be posting a link to our Google Drive folder where you can access today's training as well as training from previous weeks this year. And if you participate in the training that way, provide us with a brief summary of what you learned, you can get a certificate of attendance for that as well. Normally we would pass it over to Jose, our fire safety advocate for AFM. He's unavailable with us today for our words of encouragement. So we're going to jump right into our training session, and I'm going to pass it over to Ed. Take it away, sir.
Hey, thank you, Mike. Hey, good afternoon, everyone. Thank you for joining us. We're going to have a little bit discussion on pump operation and also water supply. This was actually kind of a challenging topic for me to put together, knowing the difficulties that exist in Africa for obtaining a continuous water supply often. That's why a lot of the class, I want to have some open discussion on what are your challenges and maybe what are some of the best practices you have found given your certain situations. Well, let me share my screen and get So to start out with, before we even can start thinking about water supply, we have to think about being the operator of the fire engine, being the pump operator. Without good solid pump operations, no amount of water will be able to put out the fire. If things aren't pumped right, if the pump operator is not aware of what he should be doing and then properly executing his job. So we want to look at some of the things with the operator's responsibility. Probably one of the biggest ones I have as far as what our responsibilities are as a pump operator is getting your crew to and from the fire scene safely. You're entrusted with their lives driving back and forth to the fire scene. It's a huge responsibility to take very seriously. Also, we're entrusted with the safety of the general public as we're driving to and from fires. It's not just we have to go deal with one emergency. Because we're going to tend to one emergency does not give us the right to endanger others. We call that due regard here in the US, where we have a due regard no matter what we're doing to operate safely on the roadways. So that to me is probably one of the prime responsibility of a pump operator is getting the crews to and from the fire safely and not endangering the public. Checking the tank water. The tank water is our primary water source. It is important that on a daily check, the operator does more than simply look at the gauge and say, oh, the tank level gauge says the tank is full. Oftentimes I have heard of experiences where people saw the gauge was full, thought the gauge was full, they went to a fire and the tank was half empty, even though the gauge said it was full. It is imperative we climb on top of our apparatus, open the hatch, look to make sure the water's full. That is just kind of one of the routines I have gotten into at my department. I teach our new operators, don't trust the gauge. Go up there, open the hatch, verify that there's water in the tank. That is kind of a big deal. That's your primary water supply. If your tank's empty, you get half of the amount of firefighting ability that you should have. A tank should never leave the station half full. It should always be full, giving us the most opportunity to fight as much fire as possible. We want to make sure that the pump works and it builds a proper amount of pressure. When we're checking our pumps every day, we have to put it in gear, bring water in from the tank, so open the tank to pump valve, then put a hand line on a discharge or even just a nozzle on the discharge, bring the pump up to pressure and make sure that we're getting the amount of pressure that we need for the nozzle, anywhere from 4 bar to a lot of the nozzles run at 7 bar. Put a nozzle on, look at the rated nozzle pressure, make sure the pump can develop the proper pressure for that nozzle. So now we've checked our water supply and we've checked that our pump's operating. We have a lot of the equation for a successful fire operation done already. Our valves work, our pump works, and we have water to go. Understanding where all the valves are, this is a really good schematic that I saw on a truck. Actually, it's out of a Nairobi engine. It has the full layout where all the valves are located and everything in between. And this allows the operator to have a really good understanding of how his pump operates and his whole engine operates and the system's laid out. If your engine doesn't have something like this, it's a really good exercise to crawl under the engine, trace out all your plumbing, find out where all the valves are located, giving you the ability to be very, very familiar with the system. And it really helps out from an operator standpoint to know how everything is located and plumbed. Helps us troubleshoot when there are issues. Instead of maybe going back from the beginning, now we know, okay, there's a valve in between the tank and the pump that's an extra one that might be sticking. Let me go check that. Opposed to, well, I've got to go all the way back to engaging the pump and going through all this stuff to make sure I have water. It's more advantageous to be able to know everything in your system, what type of valves, what size they are, and it helps a lot when it comes to troubleshooting and just overall operations. Just because there's a pump on an engine or a tender doesn't mean that it's going to give us the amount of flow that we may need for fire operations or water supply. All engines have a plaque somewhere on them that tell us how much flow and how much pressure each pump will be able to produce. For this one, an example out of a water tender, it's able to, at 10 bar to be able to produce 3,000 liters per minute. This may or may not be enough to support our water supply needs for a fire. Given that, we might have to use 1 or 2 of these pumps to be able to supply our total amount of water. And we'll talk about that a little more in the water supply section. This is why it's very important to understand how much water a pump can supply. As if we have, say we have an attack engine that's capable of flowing 5,000 liters per minute, the water tender may only be able to, in this case, supply 3,000 liters a minute. The maximum flow we would be able to have on our fire ground would be limited to the smallest pump, unless we do something to combine multiple tenders, in this case, to be able to supply an engine at a higher flow rate. Oh, it's kind of the first step in knowing how much flow we have available is to know the capacity of our pumps. Oh, And just the other thing, know where all your tools are located. This helps the fireground operation. It helps you as an operator. It helps the accountability to make sure if tools come off of the truck, that those tools will go back onto the truck, and that you're not missing things at the end of the fire. The other thing as a pump operator you should be able to do is know how to operate most all the tools that are on the truck. If someone in the station, if they know you're the operator, they'll go, hey, here's a tool. How do I use it? You know, they're going to be coming to you not only for where it's operated. If they don't know how to use it, they're like, well, you know the truck, you're on the truck all the time. How does this work? The operator should have a working knowledge of all the tools that are on his truck. We have many different types of branches that will go onto the end of our hose. We have different size hose. All of this goes into the pressure that we pump, that we use for our pump discharge pressure. It's important to know what pressures we will pump our lines at to develop the proper flow for each branch. This also goes back to water supply, knowing how many branches we have pulled off of our truck, how much each one of those branch is flowing will tell us how much water we will be needing for our fire ground operations. For example, if I'm flowing 2 branches that each have 100 liters per minute, then I'm going to need of a minimum of 200 liters per minute for my water supply. If I have 11,000 liters on my tender that's with me, that gives me roughly 10 minutes. Well, 210 would be 2,000. I'm looking at probably a little less than 10 minutes of water supply running that amount of water in our fire ground operations. That's part of being an operator, to know how much water you're flowing, how much water you have, how long this will last us for our operations, relaying that information to command to say, here's how much water I have. And then as the water tank drops down, you call command and tell them, it's like, okay, now I have half a tank. If we pull any more lines, we're going to run out of water faster. If they start saying, well, we need to pull more lines, we need more branches in service, you can say, I don't have enough water to do that. And it's up to the operator to know and be confident enough to say, here's how much water we have. We can flow this many branches for this amount of time. And then, your pump panel is your office, and you should be the one that is opening valves, getting tools ready for people, connecting lines to the pump, allowing you to know what is going on at all times with the engine. Otherwise, if people just start running up, putting in hoses and opening valves, you'll lose track very quickly if other people are doing things about how much water you're using, and how much water you're flowing. That will impact the water supply you have available left over. Keeping control of the pump panel and your office of the fire engine is important when we're laying out water supply and trying to remember and know how much water we have available, to prevent people from just randomly connecting hoses, starting to flow water, opening valve without your knowledge. Also, when that happens, you will not necessarily increase the pressure quickly because you don't know that someone opened another valve on you, or you also won't know what type of branch they have at the end of the hose. Not knowing that prevents you from pumping the system at the proper pressure, supplying it with the proper amount of water. And then, we really want to train on our apparatus to get the best understanding of how it works and be able to effectively and efficiently use the water that we have available and that we carry, and that we're not wasting not only water, but wasting time as we're starting to connect everything to our pumps and get the water flowing into our fire ground operation. And take pride, take pride in the fact that you've been entrusted with this fire engine to be able to drive, to operate it. You've been entrusted to have the knowledge of how much water it takes, how much water it can supply, to give your brother and sister firefighters the ability to fight fire as long as possible and keep them safe by supplying them with the proper amount of water to do their job, and making sure that they will not be running out of water at an inopportune time in the firefight. Those are kind of a lot of your responsibilities as the operator. It's a lot to deal with. Takes a lot of training, a lot of knowledge, and oftentimes it just takes setting down and looking at how things are laid out. So once we look at our responsibilities, start out, everyone's pump controls are a little different, but we're just going to kind of review kind of what I've seen in Africa as kind of a standard as the European style of fire engine, with the rear mounted pumps and the controls being right there at the, right where the pump inlets are. You're right at the back of the engine. All of your controls are fairly simple, right and rightly accessible. The big thing is use all of our senses when we're operating the pump. You want to look at the gauges, look at your lever positions on your valves, look at what hoses are in operation, where they're going, and also keep an eye on kind of what the fire conditions are. We're going to listen to radio traffic to find out what's going on at the fire ground. Listen to the engine RPM, listen for any noise from the pump that would indicate we're close to cavitation or there's some other issue that we need to address. And make sure that there's not just kind of, that gives you an overall sense of listening that the truck's operating properly. And then when we use feel, we can feel the pump vibration. If we're being supplied by another engine or off of a hydrant, we can make sure we can feel that supply line and make sure there's enough pressure in it and providing the flow. That's how we're using the feel portion of it. We want to use all of our senses when we're running the fire engine. And the big red button, which we really don't ever want to use just to shut the system down. It is an emergency stop that you're going to use to prevent damage from occurring to the pump if your engine has this. Under normal operations, we won't use it. Some trucks have a monitor valve, very straightforward monitor valve, open switch. Now, there's the valve that allows you to fill your tank from the pump. We want to make sure that we limit the pressure going to our tank from our pump to about 5 bar or less to prevent damage to the pump. We want to check our pressures as we're trying to fill our tanks to make sure we don't overpressurize them. If we have a drain valve, make sure all your drains are closed. If our drains are open, we're wasting our water supply. that water, instead of going from our supply into the pump out to the fire grounds, will go from our water supply to our pump out a drain and is wasted on the ground. Then know how your pump throttle increases, know which way makes the RPMs go up, know which way makes the RPMs go down. Increasing RPMs to your pump, we increase flow and pressure from the pump. The faster the pump spins, it's able to generate more pressure and more flow. As we reduce our RPMs, we generate less pressure and less flow. It's important to know which way we're taking our RPMs in the fireground situation to provide the proper flow and pressure. Make sure the pump's engaged. This is actually, and even in the US, when I've been on some fires and have taught some classes, one of the big things that firefighters sometimes will forget to do in the excitement and rush to get, pull out hand lines and get water on the fire. And it's like, yeah, we got a fire. They'll forget to put the pump in gear. They won't turn the PTO on. They won't put the transmission in gear. It's important that we take this step and then verify with whatever means are given to us, either light on the panel, or often we go back to using our sense of sound. You can hear that the pump's running, making sure that it's in gear, running, ready to go. Then you should have some type of lights or gauges to indicate any trouble with the actual truck motor, like low voltage, low oil pressure, high temperatures. And the water tank gauge, you want to make sure you know where it's at. You want to make sure it's operating. Oh, as we talked about before, turn it on. If it says 100% full, you need to get on top of the truck, open the hatch, and make sure indeed it's 100% full. If it's not 100% full, then we need to start investigating what is the issue causing the gauge to not read properly. And it's imperative when you're operating, when you get to 25% of your water, tank water, to inform command, that lets them make some strategic adjustments either in the firefight or the water supply. They'll either know that, okay, we need to get more water, or there's more water coming, or we need to maybe shut down a couple hand lines, pull our firefighters back just to keep them safe should we run out of water. These are things that, as the operator, you have to relay your water supply levels to command to allow them to make the proper decisions. And the tachometer simply is going to show us the engine speed, makes us aware of how fast the motor is turning. Also when we do our pump check, sometimes if we know we flow one nozzle all the time at a certain RPM, if all of a sudden that RPM starts to change with that nozzle, either there's something issue with the nozzle or there could be an issue with the pump. As time progresses with pumps, things will wear down. They will get less efficient. And looking at your discharge pressure and flow for a certain branch, comparing to the engine RPM, if you do those tests once or twice a year, you'll be able to track to see how my pump is performing and potentially degrading. So that's another thing we want to use our tachometer for, to show, kind of look at how the pump is performing. And the gauges, usually we have 2 gauges on most of our engines. You'll have an intake gauge that will be 0 or less if we're pulling from tank water or we're pulling from a draft. And then our main discharge gauge is showing the pressure that we're providing to the outlet piping. and this should be matching the needs that we have for the given branches we're using. If we're using a 7-bar branch, we want to at least be pumping 7 bar for our discharge pressure. If we know we have a more like a long length of hose, we'll probably be pumping at 8 bar just to overcome friction loss for that branch in the hose line. Some engines will have individual pressure gauges for each discharge, allowing the operator to optimally adjust the different discharges to match the branches that are used on that discharge. And often, well, with a high pressure system, if you have a high pressure line, the high pressure system will also have a gauge for you to be able to see how much pressure is going to that system. Again, we've talked a lot about this. They tell you, your gauges will tell you how your crew's doing. If all of a sudden pressure drops, that could be an indication. If your inlet pressure is still the same, you have a drop in your discharge pressure, that could be an indication a line broke. If it increases, an increase in pressure would indicate that the crew shut down the line, or there's a large kink or an obstruction with the line that needs to be investigated and fixed if need be. Your gauges tell you how much water you're going, the condition of the pump. Hopefully we have fuel levels, to prevent us from running out of fuel. Most of the engines I've worked on in the US do not have a fuel level gauge. And my department, one of my friends almost ran out of fuel pumping a fire because he did not have the fuel gauge on the pump panel, and he had forgotten to go into the cab to check with the fuel gauge, the fuel level. These are things we need to make sure we're checking when we're operating. We can have all the water in the world, but if we run out of diesel and the truck stops, doesn't do us much good. If we don't have the ability to run the pump, no matter how much water we have, it doesn't really make a difference. So our initial primary water supply, I would say, Africa's fairly, in this terms, like us in the US. Our primary initial water supply will be our tank water. And the reason, we use it, we carry it with us and it's readily available. But as your overall water supply goes, we want to ask, what resources do we need for water supply? Where are we going to get these resources? Especially when other companies and fire brigades may be an extended travel time away from you, you want to call them early, to allow them time to get there to help you. Then the whole water supply, who's managing that? Is that a separate branch in the IC system? Is it the pump operator? Often it's the pump operator in most of our fires. And then how are we executing getting water? Are we just using the tank? Are we getting it from a second engine or a tender? Do we have a hydrant available? Are we going to use some other type of water supply operations, be it portable tanks, be it a static source that we're close to? Kind of what are our options to be able to execute our supply system? But always, no matter how big of supply system we're going to use or build out over time, we're going to start with the tank water. It's fast, it's efficient. We know how much water is available, and we can get it to the fire fast. And often that's in Africa, all the water is available is what's on the truck. So you use your tank water. When the tank's empty, you have to go refill the tank. This is why it's important to have other brigades, other engines on its way to allow you to be able to refill your tank without leaving. This also looks at some of the things of maybe breaking the paradigm of always using big engines at the fire scene. And maybe we do something smaller at the fire scene and let our big engines with larger tanks move water back from our source to our destination where we're using it. Maybe other options of using a small portable pump to supply our hand lines and pull water out of a portable tank, allowing the water to be shuttled back and forth with our engines or our tenders. What our tank limits on our water is it's a limited size. We're looking 3,500 liters to maybe 11,000 liters in a tender. The flow, fortunately, on most of the engines I've dealt with in Africa, the plumbing is not an issue. In fact, I would say the plumbing and the flow rates available in the engines I've dealt with in Africa, they are better than the flow rates I have from my tank to my pump in most of the US engines I've dealt with. That's one restriction you won't have to deal with the way your plumbing set up, but also you need to know to make sure your plumbing, how big is that line going from the tank to the pump? The smaller it is, the less water it will flow. The bigger it is, the more water it will flow. The one thing people don't often think about when it comes to getting all the water out of the tank and how much is the impact of truck position. If I have the truck parked in a manner that's either sloped up or downhill, it could either push the water towards my inlet, the outlet of the tank, or it may push it away from the outlet of the tank. That will have an impact on how much water I have available for my water supply from my tank. The first thing we do when we'll show up, the first water on the fire from the tank. We position our engine, we stop it, we put the pump in gear, open our tank to pump valve, and then to recirculate, as long as you're below 5 bar, we're going to open the tank to pump, the pump to tank valve just a little bit. That allows water to circulate. And then that gives us, while that's circulating, cools the pump, gives us time to connect all of our hoses, get everything ready. And then when the firefighter's ready to open the discharge, open the bail on the branch, we're able to open our discharge valve, close the tank fill valve or pump to tank valve, and then we'll increase the throttle as needed for that branch to be able to start a fire, fighting the fire. And then as they go on while fighting the fire, you're going to monitor your tank level and try to, if you have the ability to secure an additional water supply, work to secure an additional water supply. And this is, if we look at the picture on the right, the tank to pump plumbing, most of the trucks in the US I've worked on, we have maybe a 1 inch, so maybe a 50 millimeter line going from our tank to our pump, where most of the trucks I've seen have closer to 100 millimeter line in Africa going from the tank to the pump. A lot of flow in that. And then tank fill is always just a smaller line. Usually that's like a 25 millimeter line, maybe a 35 millimeter line going from your pump to your tank to fill and also recirculate water. Again, it's the operator's responsibility to be connecting the hose and opening the valves when the firefighters are ready for water. And monitoring our tank levels, and then securing our water supply, either from a hydrant, if those are available, or from a water tender, once a water tender arrives. Now, one thing I have found with the water tenders having smaller pumps, sometimes you will actually have to hook 2 water tenders up if you're doing a high flow firefight to be able to fill, either supply the pump or often what I found, the way the plumbing is arranged on many engines, it's often simpler just to supply water directly to the tank of the attack engine, um, allowing the operator not to have to adjust for pressures on the incoming um, inlet line that would be coming from the water tenders. This allows the tenders to simply fill the tank and the operator just be pulling from the tank water, and he doesn't have to change his operation based on the water tender's operation. That's actually a really good option that you have, is just allowing the tenders to fill the tank on the attack engine. If you have access to fire hydrants, often we look at putting a second engine at the fire hydrant, and then that engine would supply water to the attack engine. Oh, it's our standard mode of operation to work that way. And for several reasons, especially with the hydrants I've seen in Africa, they're very low pressure. They would not have the ability to push the water very far to the fire grounds or to the attack engine. That second engine on the fire hydrant will actually help boost the pressure, help maximize the flow going to the attack engine. And should anything happen to the attack engine, then that engine can simply take over and boost the flow and boost the pressure. Now, using the direct tank fill, and this picture actually shows what I was talking about. We have two lines going to fill the tank. One is coming from one tender and the other line is coming from a second tender. This allows a lot of water to be flowed from that engine, even though we're flowing more water than a single tender is capable of supplying. And the one thing when you're filling from a second engine, filling your tank, you must make sure that their pump discharge pressure is less than 5 bar. And honestly, your second engine, and I've seen a couple different things work. I've seen where the second engine shows up and they start pulling lines off of that engine. It's really not the most efficient way to use the water that's on that second engine. And it means there's a lot of equipment off of that second engine that's on the ground. The best way to use the water from that second engine is to run a hose from that second engine back to the first engine. And then that second engine provides the water to the first. Once that engine's empty, he simply has to disconnect one hose and then go back to wherever they can fill the water tank. If they start pulling attack lines off, then when that engine's empty and the first engine's empty, the only way to fill water is to disconnect all the attack lines and then drive to refill. If that second engine just supplies the supplied their tank water to that attack engine through one hose, there's only one thing that needs disconnected, and that there's only one engine that's going back and forth for water. One thing that will help water supply, if you have portable tanks available, you can set up a portable tank and draft from it, and that second engine can come dump its water into that tank and then drive away. This is where some things also flexibility. If you have a portable tank and a portable pump, you can use those, pull those off, use those towards supplying your attack lines, and use your engine to run back and forth to get water. Another option using portable pumps and portable tanks is what we call an open relay. You would put a portable pump in like a lake, a pond, a river, and that would pump into one of these portable tanks that you would have set up next to your engine, allowing you to get water from that source. You would draft from the portable pond, and then use that as your fire attack water. The other method to use one of these open relays works really good in a city setting. If your fire hydrants are very low flow, they won't support fire attack. You can take one of these portable ponds, set it up next to the fire hydrant, open the fire hydrant just to flow directly into this portable tank, then draft out of the portable tank, and that tank acts as a buffer of water to be able to fight the fire at a higher flow rate than potentially your fire hydrant could provide. These are just some tools to be a little more flexible using the open system of portable pumps and temporary portable tanks to set up to give us more options with water supply when it's, kind of a scarcity of resource that we need to try to optimize what we're, how we're dealing with it. So that is what I have for my presentation. Right now, I'd like to, since this is kind of a challenging topic of what do we do for water supply, when we're limited, and how we can optimize and maybe find relatively inexpensive ways to improve how we can do our water supply. I'd like to open it up and we can just kind of have an open forum now. Does anyone have any questions, comments on this?
Go ahead, Derek.
Yes, I think I have a. Hi, good evening, Mike.
Hello, how are you?
Fine, thank you. Good evening, everyone.
Go ahead, sir.
Thank you. I've been following. First of all, I thank our day's instructor for the good communication he had for us. One thing in Kenya, for example, when we talk of the fire hydrants, I don't think we have enough fire hydrants where we can set up our vehicles ready to fight fire. When we leave the station, the water we leave with from the station is the same water we are going to use until we make local arrangements to have either the water boozers from private companies, or we make a follow-up with some other companies to have this to have some water. What will the African maybe fire mission or our counties do in order to make sure that we have the hydrants back in our cities? Because some people have built houses on top of the hydrants, or have diverted water because of corruption. They have diverted the water for firefighting to their houses, to private houses. How are we going to deal with such behaviors? Thank you
one
so
way
much.
to do that, that comes down to, especially when people divert water and build on top, that comes down to your local community and your building codes and enforcement, and the relationship your fire department has with the community. So to me, that would be, we need to advocate for people, to the government, and also advocate to people who do things like this, the need to keep the fire hydrants free. And I understand, you don't have a lot of fire hydrants, but you should have the ability to use the fire hydrants that you have. And if people are doing things that inhibit this use, then that's where building the relationship to be then able to talk to them and discuss how they're potentially impacting their own safety and the safety of the community. But things like that all comes down to the fire department advocating for better water systems to the government, and also educating the public on the proper use of the water system and what the water system, the purpose of that system truly is.
Very true. But one thing, there's a lot of intimidation to the maybe fire officers who are going to check on the hydrants. And the ones intimidating them are the same people who employ them, maybe their bosses. For example, a very senior county government or a national government officer has diverted the water to his house or to his shamba garden. Now it becomes very difficult for a fire officer to go and push them to maybe direct the water to the hydrants. And when you are directing the water to the hydrant, maybe you know you are going to deal with your boss. There's that respect now.
Well, there is always that, and that comes a lot of education and rapport building for everyone, and often honestly, depending upon how they divert water from the fire hydrant, unless they actually valve out the fire hydrant, you should still be able to get water from it. And usually if you start pulling water from that, the fire engine will win and actually get more water, even if they've tried to divert it, unless they physically valve out that fire hydrant and take it out of operation. If they simply run a line from the fire hydrant to, their house, their garden, or whatever, when we start to take water from that fire hydrant, we will get water from it. And we will probably get more water than they will during the time that we need it. But again, it goes down to advocacy and education, and for the general public, that is one thing we have decent in the US is education, and people understand the needs for water. We do have sometimes that people cover up fire hydrants. I've had to dig out fire hydrants when people put their landscaping on it. But ultimately, like if you're dealing with county government and an official like starts taking water, it's like, part of your job as an official is to provide for the safety and protection of your community. How is watering your yard providing for the safety protection of the community when it takes away from the fire protection capability? There's no real easy answer for it, but over time you just have to develop rapport and education to be able to do that.
If you have any other questions, Adelino, I see you've got your hand up, sir. Go ahead. How's things in South Africa?
Hello, good afternoon. How are you guys?
Very good, sir.
Yeah, I just wanted to just put some input on something on the potable tanks. In terms on my operation, what I did in most of the cases, where in a situation there is no ponds, river, or any swimming pool around, in a situation where the fire is the incident is big, what we did is we take like 4 ladders and salvage sheet and build a dam, a potable dam on it, and then they start water shuttling on it, and then we draft from it, and then makes the operation much easier.
Yeah, that's if you don't have like pre-made water tanks like we do in the US, that the ladder and a tarp, those are perfect to build up a level of water containment tank.
What other challenges do you guys face that maybe you've got some questions about with related to water supply? Today's topic of the day. Anyone else? Go ahead, James.
Yeah, hi, good afternoon, everybody. I guess my biggest question is probably one of the major problems we have in Africa in terms of water supply. Mine would be to ask, what would be the best way to kind of go to kind of get into education for the public dealing with the water resources? Because I bet in the States it's something probably you had to overcome over time. But what method or what approach do you use to kind of educate people, like the water hydrants and the importance of water for firefighters? I'm thinking maybe we could borrow a leaf from what you do and kind of adjust it to work in our situation. Thanks.
Well, I'll say what I've seen, and then I'll let Mike chime in on kind of what they've seen. But, from our standpoint, it just goes kind of with the whole general education and outreach to the community to let them understand what we need as a fire department to be able to provide them the protective service that they're looking for. And as part of that, we educate them on the importance of water. Often, if people have ponds or lakes on their land, at that point, we'll try to get a water use agreement with them that will allow us to, pull water from those static sources or those natural occurring sources that are in their property. That's just kind of how we've done it over the years. It all incorporates into our general education and outreach to the community.
Yeah, and I think that the advocacy portion of it, if you want to get your politicians to be impacted or to do something for you, you've got to sort of make it worth their while. So that's where collecting data and having sort of hard facts and information available is really important. So when you have an incident where you weren't able to, where there was a lot of property damage, okay, because you didn't have an adequate water supply, try to get an estimate of the value of the property that was lost. And sit down and think, if we could have limited this, how much money could we have saved? How much how much lives and property can we save? And try to document that in a fact-based report, that you can go to your local politician and say, if we could secure this water supply, if we could get this available, over the past 3 months, we could have saved, X number of shillings in property loss if we had a better water supply system. And the benefits of it, when you've got lives lost in fire, we may have had the ability to save these lives. We could have saved X number of lives over the past year if we had an appropriate water supply. And this will make you, as a local elected leader, it will make you look good if you can help us to provide these services, and try to get into that cooperative agreement with them where you're working together with your local elected officials to promote that, And a lot of times it's not necessarily, I hate to say it, but it's not necessarily that loss of life that's the most important thing sometimes, but it's that dollar figure, And if you can show just having a readily available water supply saves money on fuel for the fire trucks and things like that as well. When you get the job done more efficiently, when you don't have to drive those trucks back and forth, wear and tear, where you're leaving the scene, taking the truck somewhere, loading it up, bringing it back. Okay. So that adequate water supply, show them how it can save them money, show them how it can save wear and tear on the fire apparatus that they don't have to replace maybe so often because you don't have to use it in such a more difficult way. So it's that advocacy portion, and showing them where it's going to hit them in the pocketbook. What do you think, Adelino?
Yeah, in other cases, what I think is, what about if they can go to the Department of Water Affairs and Department of Infrastructure, because they have all the maps of all the streets and everything, so that they can see which part of the town or of the village of the location does not have high fire hydrant. so that they can be able to build to construct fire hydrants on those places, because the Department of Infrastructure, they are the one who are working on those things, and then the fire chief is the one who must be responsible for him to draft a letter or to draft an act on that, so that they must be able, and the act obviously it have to go through the politician and everything, but he have to explain to the politician the reasons why there must be a hydrant.
Exactly. You nailed it right on the head. It's that advocacy, it's that promoting what you need to do, asking the planning. You've got your Department of Infrastructure, you've got your planning, and maybe there's an engineering division that would be involved in some of that planning and things like that. So a lot of great areas there where you can advocate. At this point in time, we're going to wrap up the formal part of today's training, and I want to thank Ed for taking time out of his schedule. Ed is at a large fire department instructors conference here in the U.S. right now, teaching classes there as well, and he took his morning away to join us. So Ed, thank you very much for that and all that you contribute here to AFM. It's much appreciated. If you all would please join us again next week, share it with your friends and colleagues. We'll be back here again the same time next week for another great presentation. Thank you all for coming today.